Just like the other rational expressions lessons, it's important that you understand all the factoring methods, and it's important that you are competent at manipulating algebraic expressions. You will be able to participate in several examples that will help you with adding and subtracting rational expressions when they are a little more complex. Just like in the prior lessons and the prior voice threads, I am providing the link to the memory aid tips for manipulating rational expressions. We're adding to our bag of tricks. I'm not going to read these steps for you, but these are the steps that I will use in order to add and subtract the rational expressions in this lesson. So you're going to have three examples to work out in this voice thread. The instructions are simplify the following algebraic expressions, and a reminder for all of these, the denominator is not equal to 0. Now, I did mention it in the previous lesson that the first step is always to factor our numerators and denominators. We didn't have any of those cases in the prior voice thread, but now we do. Do you remember your factoring methods? Would you please factor the numerator and the denominator? The numerator was a decomposition method. Now, I'm not going to go through all of the steps. If you're having difficulty with the steps of decomposition, go back and follow the steps for factoring using the decomposition method. Did you get the factors of 5x minus 3, 2x plus 1? In the denominator, we have the difference of two perfect squares. Did you get 5x minus 3 times 5x plus 3? So a reminder, the first step is always to factor both numerators and denominators. The next step, if there is in one fraction, and this is one fraction, one rational expression, factors that are identical, we can eliminate them. And that's what I've done here. I've eliminated 5x minus 3 with 5x minus 3 because those factors are identical. So what am I left with? 2x plus 1 over 5x plus 3. Now, what am I going to do? I'm working with rational expressions, and 4 is not a rational expression, but I could express it as a fraction so that I can focus on what the strategies are. So I'm adding rational expressions. Do you remember what the next step is when we're adding rational expressions? When we're adding rational expressions, we must have a lowest common denominator. If it's a factor in the original denominator, it's a factor in the lowest common denominator. Well, it's understood that 1 is a factor. So our lowest common denominator is 5x plus 3. What do we do next? We must find equivalent fractions if we changed the fraction. Now, this first rational expression, we didn't change the denominator. Therefore, the numerator stays the same. But look at the denominator here. We multiplied by 5x plus 3. We must Also multiply the numerator by 5x plus 3. Do you remember what comes next? It's important that you simplify your numerators before adding. Well, here it's already simplified, 2x plus 1. But here it's important that you perform that operation. You're multiplying the 4 by both terms inside the bracket. You're distributing the 4 to both terms. That will give to you 4 times 5x is 20x, and 4 times 3 is positive 12. We now have common denominators. Now we can add our numerators. We keep that lowest common denominator and we add the numerators. And we collect our like terms. 2x plus 20x is 22x, and positive 1 plus 12 is positive 13. At the end of your work, always verify. Make sure that you cannot factor it. Well, if we look at the numerator, that cannot be factored. So when it cannot be factored, we're done. We've completed simplifying the rational expression. How about this example? X plus 2 minus a rational expression, x squared plus 6x plus 5 over x squared minus 25. Do you remember what the first step is? Can you do that at your desk and then you can verify? Always factor numerator and denominator if possible. In the numerator, we've got an easy trinomial. The factors are x plus 5, x plus 1. The denominator, we've got the difference of two perfect squares, x minus 5, x plus 5. What do you think the next step is? Notice in this one rational expression, if you see in the same, it's got to be in the same rational expression. If you see that you have identical factors, you can eliminate them. So you've made your problem a little simpler. You now have x plus 2 minus a rational expression. The next step, you're subtracting. You're subtracting, that means you must have a common denominator. Now, x plus 2 isn't a rational expression, but we can make it a rational expression by putting it over 1. This is equivalent to x plus 2. Now it's simpler to see what the lowest common denominator would be. Why don't you try to find that lowest common denominator before I show you? If it's a factor in the original denominator, it's a factor in the LCD. Well, 1 is a factor in any denominator. X minus 5 is a factor in this rational expression. Therefore, x minus 5 is a factor in the LCD. The next step is to find equivalent fractions. You've got to verify how the denominator changes. The denominator changed from 1 to x minus 5. In reality, you multiplied 1 by x minus 5. Well, you changed it by multiplying by x minus 5. You must multiply the numerator by x minus 5 as well. This second rational expression, the denominator did not change. Therefore, the numerator does not change. So this is where we are at now. What do you think the next step is? After you've worked with your equivalent fractions, after you've found your equivalent fractions, the next step is you focus on the numerator. You've got to simplify the numerator. You've got to use your rules of algebra. Notice, we've got a binomial times a binomial. You're going to FOIL. X squared times x squared is x squared. X times negative 5 is negative 5x. Positive 2 times x is positive 2x. And positive 2 times negative 5 is negative 10. So the next step is to collect your like terms. You should get x squared minus 3x minus 10 for your numerator after you've FOILed. Did you get that? And as I said before, you focus on the numerator. Now that your denominators are exactly the same, you can keep that lowest common denominator and focus on the numerator. But remember, you've got to be careful here. You're subtracting x and you're subtracting positive 1, which gives to you minus x minus 1. Then what would you do? You would collect your like terms. X squared, there are no other like terms with x squared as a variable. But you've got negative 3x minus x, which is negative 4x. And negative 10 minus 1 is negative 11. So after you've simplified that numerator, you have your lowest common denominator, you have your rational expression, but then the last step is to verify. Can I factor the numerator? No, you cannot factor the numerator. Therefore, we're done. How about this example? Do you know what to do? Do you remember what those steps are? Again, try it without looking at my answers. You've recognized that it's addition of rational expressions. Factor both numerators and denominators. If within one fraction you can eliminate identical factors, you go ahead and do that. And that's the case. We can eliminate x plus 2. What are we left with? In reality, we're left with 1 over x minus 2 plus 3 over x minus 2. What are we going to do now? We've got to, well, wait a minute. We don't have to find a lowest common denominator for this example. We already have common denominators. We keep that common denominator and we add the numerator. Therefore, our final solution is 4 over x minus 2. Now I've just gone through the steps for just a few examples. And I hope you realize that there are many other examples. It's important that you practice more of these. Keep these steps in front of you when you are adding and subtracting rational expressions. Good luck.